from how you come back. If I get the molecule right. 5,6-diethyl. 2,4,8. Trimethyl. Decade. Now let me put your molecule 5,6-diethyl 2,4,8 trimethyl decade, because there was a molecule here on the bonus quiz. Now, for example, you want to go ahead and draw the molecule. We'll try to figure out what process we can use in order to draw this molecule. In drawing the molecule, we're going to start from the back and work our way forward. The first thing we need to do before I draw the molecule is find out the longest carbon chain. The longest carbon chain, which is the parent name, comes from the back of the molecule. The first thing you do is look at the back, you get the molecule decade. What does decade tell you? You got 10 carbon atoms, what type bonds? Single bonds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2, 3, 4, 5, 6, 7, 8, 9, 10. Can we also draw the molecule? Not a bad idea to go back and recount. Lots of substitutes either missing a bunch of problem stuff here because they miscount their numbers and get some wrong little set and stuff up there. Now, unlike when they actually have to take a look somebody else's drawing and then do the number and stuff, you got to go back and forth. When you drawing it, who gets to determine what direction you go in? You do. So now, if you like doing left to right, you can already go ahead and pre-number it left to right. You don't have to go back and do backwards and forward and stuff as far as you're drawing. When you drawing it, you already setting what direction is go from 1 to 2. I mean 1, 2, 3, 4, 5. Are you going left to right or right to left? I would recommend left to right because it's the way you naturally count anyway. And I always try to do stuff that will kind of more natural. So you can always pre-number your numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. By putting numbers, also another way of recounting, make sure you got the right number of carbon atoms. Now, on carbon number, you can stop at the top. On carbon number 5, I have how many carbon atom groups? 2 carbon atom groups. On carbon number 6, I have a 2 carbon atom group. Now, give you a top or bottom, doesn't matter. The only thing that matters for here is that your group is actually attached to carbon number 6. It can be attached to carbon number 6 at the top or carbon number 6 at the bottom. The only thing you're looking for is that the attachment is to the exact same number of carbon, which is carbon number 6. Top and bottom really not going to make a difference as far as the name of the molecule. Now on carbon number 2, I have a 1 carbon atom group, which is a methyl. On carbon number 4, I have a 1 carbon atom group, which is a methyl. And on carbon number 8, I also have a 1 carbon atom group, which is a methyl. Yes?
Did you have carbon attached above the chain and that count as 1 and then below count as the other, or does it count as a chain?
You tell me, let me try to say, maybe try to say like a picture about what you're referring to. You're saying on number 6, if you have what again?
If you had a carbon attached with a 6 on it. So would that count as 1 methyl and then
If I had a 1 at the top, 1 at the bottom. If I do this number here, I will have not just 3 metals, I have 4 metals.
No, I'm separate from this. Separate from this problem. If you had, just for instance, you had a carbon attached at the top where the 6 was, would that count as 1 methyl?
Let me try to figure out like some kind of visualization type thing and stuff too. Let me give 1, 2, 3, 4, 5, 6, whatever number. I'll get 10 again. 1, 2, 3, 4, 5, 6. And 6, you got 1 at the top, 1 at the bottom?
Or in another one at the bottom of one of those. make them WC. So would that count as one methyl and one ethyl, or would that count as one?
It'll be basically saying this, these right here are part of the chain.
Yes.
Your boxes cannot incorporate the atoms in the chain.
Right.
So I can't then go jump here, because that way I would end up incorporating that carbon atom. That carbon atom is already taken forward because it's part of the chain. IAM's boxing was not part of our chain. The chain actually split this molecule into two pieces, one at the top and two at the bottom. So I have one piece and another 2 carbon atom piece, but not a 1,4 carbon atom piece. Because the 1,4 carbon atom piece means you just now got 1 carbon atom, you try to make it do 2 things. You can't be part of the longest carbon chain and then also not part of the longest carbon chain.
We should still get the same answer though, right?
Well, you talking about this one or something?
No, for like, for instance, on this one right here, the first one, for number 5, you know, you have the 2 carbons on top. So if we put one at the top and one at the bottom, we'll
It's still because it's, all we look for is attachment.
Okay.
We have this group attached to carbon number 5. It can be attached to the top or attached to the bottom. It's still attached to carbon number 5.
So one at the top and one up.
The reason why they put top and bottom because it just makes it not have all the things all cluttered together. If you want to put both at the top, it's still the same. Or both at the bottom, it's still the same. The only thing we ask for is the attachment. Is my group attached to carbon 5 or not attached to carbon 5? If I put it at the top or bottom, if I put it at the top, am I still attached to carbon 5?
Okay.
Yeah, if I put it at the bottom, it's still attached to carbon 5.
I wasn't asking that. What I was asking was like one at the top and one at the bottom. Instead of putting both of them at the top, if we put one at the top and one at the bottom, it's the same. It's still the same.
Yeah, because it's again, it's attachments.
Okay.
No, she means
No,
like,
if you
if
separate-
you separate the two C's,
It's
put
got
one
a
at
C
top.
line.
Oh no, see if I got C,
No,
C
it's
separate, that's not 2 the same thing. It's not 2 together. If I got one at the top, one at the bottom, that's 2
That's
methyls.
nasal, yeah.
Okay.
Those are
That's what she was
Yeah.
saying.
No, this was saying, those are not two the same thing.
Okay.
They're like a piece of one and a piece of one.
Okay. Sorry.
Because you can't connect those two without incorporating that group there.
Oh, yeah,
too.
then it'd be nothing to say. Okay, got it.
Yes.
And then you would like to look at 6,6 dimethyl, right? If you was just that 6
You
section.
know, you put all the methyl groups together. If it was just that group of molecules, you try to put the things together. If this right here was none of the rest of the parts put together, then that would be, you would say 6, comma 6.
Yeah.
So there are 2 groups, each group got to have their own numbers.
Okay.
Even though both are in the same carbon atom, which is fine, you still have to, for the reader, you have to specify which atom you're talking about. You can't, you know what I'm saying, I put on carbon number 1 and you know the next going to be on carbon number, if I put on carbon number 5, you know the next going to be on carbon number 5 also. That's not always true. To be dimethyl, it could be any place, the second one could be any place. It could be both on carbon number 2, it could be one on carbon number 2, one on carbon number 8. One could be on carbon number 2, one could be on carbon number 7. To eliminate any doubt about where it's located at, that's why you specify where you want the next group to be at. It's not just so you know what I'm talking about. Put the next group stuff on there. You can't just put 5 in it, so you know the next one will be on carbon 5 also. You have to state it. Yes.
So you have, right now, it's A and E is all one single bond. So if you somehow had another, like a double bond in there, then that's when you change it to E and E? Like just.
Yes, as long as you got one double bond, you will call it the E&E group.
Okay.
Now again, what we can do for the first example, we're not doing any double bonds or triple bonds. We eventually get some double bond, triple bond and stuff here, but not yet. Because again, I want to try to hopefully at least get it down to we can be comfortable handling double bonds. Single bonds. Because also before we end up going to even double bonds, we also got to form a ring. If you like it, you need to put a ring on it. So we got to put a one little rings. Anybody have any other kind of combination you may think about which you may have a question about? Because again, any kind of, maybe some different combination you may have, somebody else may be thinking about the exact same different combination. Yes.
So when we got to figure out the longest chain, show us like the shape or how it's not supposed to. Because when you're saying up and down, you don't
Let me
even.
try to get one which kind of up and down. Get one.
That's the longest, right?
Yeah, right.
That was the longest. The one you started.
I was trying to find a different little way of asking what I was doing. Because you actually have to do a whole bunch, a couple of zigzag things and stuff on the barbecue too. Make it this way, maybe.
It's the same.
Yeah. You still there?
So let's just say they were the same. Can you
So-
choose either one? Can you
Never,
choose
even
either
in the same with you, either one of them. But that's why I said I try to fix it, it's not both the same. So if I got this molecule right here, and I can put a French on that one. I was starting to do my count. 1, 2, 3, 4, 5, 6, 7, 8, 9. My initial number is 9. I just because I come with 9 and stuff, it doesn't mean it will stay 9. I would then do different combinations. Can I get better than 9? I can start, notice for you, I kind of randomly started right here. There was nothing that says I had to start at this point right here. I'm just randomly picking this point as a starting point. So I can go 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7. 7 does not beat it out. As far as this group right here, the longest one would be going across the day. But that doesn't mean it's always the longest one. Even I gotta look for here. Can I get something longer by starting right here? I can start here, for example, start here from the point, kind of work my way over. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. Because I randomly picked this in to do my different combinations. Once I went down, once I get down, I can't then go back up.
Okay, so if
Once I
8
get down, I
was,
can either go this way or that way.
so if 8 was your highest one, could you do that like that down?
Yes,
down?
there was 8. Remember, we got at least a 9.
Right.
9 would be the winner until you get something greater than 9. Yes.
So is it possible that you can start from the C to the top?
And come-
So-
One of us said, I would do this going random because there's no, it's not set that I have to start right here.
No, I'm just asking
The
in
C at the
general,
top.
so if
Uh-huh.
I wanted to, I could start from the top.
Yes, but also we just going through the process, we're just going through the steps of how you're going from. You started right here, just kind of working our way over. Just because I started here does not necessarily mean that will be the longest chain. I did this for here, I got a number of 9. 9 so far is the longest. I did it a couple different ways. When I did this for here, when I got here, I can either go up, go down, as far as the super far. When I get here, the 2 branches. Once I go up, I can't go back down. Once I go down, I can't then go back up to the particular part right here. So now I take this part right here and start from the end. 1, 2, 3, 4, 5, 6. Now when I get to 5, there's 2 options. I can either go back this way or I can go the other way. Now whatever way I decide to go, I can't go back again. Once at this point here, I get a point of making a decision. Once I decide to go here, I then can't just go back. Once I decide to go down, I can't go back over here again either. So at this point here, I go 1, 2, 3, 4, 5. Now I have 2 choices, either go this way or go that way. If I go 6, now at the point of 6, there's another branch. I either go this way here or I can go back down. So when it gets to the point of when you got to branch out, once you get stuck into either going left or right or top or bottom, you're committed yourself to go in one direction. Once I committed to going here, I can't then go back and use these numbers right here. Once I go back down here, I can't then use these numbers right here. So I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 is a chain that beats out 9. Now again, we're going back and forth. Once you commit to either going up or down, you then can't decommit and say, nah, I change my mind in the middle, I'm gonna go back the other way. Once you commit to go in one particular direction, you have to stay in that particular direction. So for this molecule, your longest carbon chain is right here. Now, when I do my longest carbon chain, I have to weigh two ways to number it. I can number from top to bottom or bottom to top. And this number I'll go from, my box will be here, box here, box here. So I have 3 boxes. How many carbon atoms in this box? That'll be your methyl. Ethyl.
And crop. Propyl.
Propyl. Propyl. Now later on we're going to talk about this. Now in methyl there's only one methyl, there's only one ethyl, but there's 2 propyls.
Huh?
There's 2 different type propyls. When you have 3 carbon atoms, there's 2 ways you can actually attach 3 carbon atoms. I can either attach to carbon 1 or carbon 2. So there's 2 possibilities attached to it. If I was just at 1 carbon atom, there's only one way you can attach to 1 carbon atom, which is carbon 1. If I had 2 carbon atoms, there's only one way you can attach to carbon. There's only one way to attach to 2 carbon atoms. That's through carbon 1. Just because where the direction start will become carbon number 1. But again, I want to get to the little numbers about like the different types of propyls and isopropyl groups. I mean, different type of propyl groups and different type of butyl groups. But again, we're focusing on about like trying to find ways in which you can zigzag the lines and stuff on that. If I would get another example about zigzagging, or trying to find the longest carbon combination. We can't do it. We can't do some more.
So you're saying it'd be a different propyl, like off that middle either, or off the middle carbon, another carbon that was branched off that carbon. That was
You're talking about the longest chain. You're talking about the side.
I'm talking about the branch, the propyl.
The branch.
Yeah.
Let's look at like 1 carbon atom.
We could just say right here.
I'm going to try to explain how we get this. Why I say there's more than 1. If I had one group, because of symmetry, there's only, I mean, in fact, if there's 1 carbon atom, only attached to one atom, which is just 1 carbon atom. If I had 2 carbon atoms, I have 1 and 2 because of symmetry. By folding it over, both carbon atoms are carbon 1. If I attach this carbon atom at the front, that's carbon number 1. If I attach the carbon atom in the back, that's also carbon number 1. But when I get 3 carbon atoms, 1, 2, 3. Can I take a line and fold my carbon atoms over and make any carbon atoms identical?
Yes.
1 and 3.
If I put a line through carbon number 2 and fold it over, I will make carbons 1 and 3 identical. Got to see it? So I fold it over, I will make 1 and 3 identical. Instead of having 2 different numbers, I'll make both of them being 1. Now when I attach something to those 3 carbon atoms, I have 2 places I can actually attach it to. I can either attach it to carbon number 1, which is on both ends, or I can attach it to carbon number 2, which is in the middle. Now I have 2 different arrangements. Because I have 2 different arrangements, I cannot use just one name for those 2 different arrangements. Because remember, in the name of the molecule, you have to specify what type of arrangement you're dealing with. So because we have 2 different arrangements, we have to specify what arrangement. We have to have 2 different names to correspond to the 2 different arrangements. One arrangement which is attached to carbon number 1. You notice this molecule right here, I am attached to carbon number 1. One of those outside carbons. Equally, I could have had an arrangement which I was attached to carbon number 2. Because there's 2 different arrangements of the 3 carbon atom units, I cannot use the same name for 2 different arrangements. So we had to come up with another name to explain the individual arrangements. I'll do a little later. But it does kind of pop up some of the other stuff that we have to cover a little later. Yes?
So then if you were to attach it at like 2 instead of 1, would that create a different isomer?
You would get a different connection. So one is called N-propyl, next one is called isopropyl. Somebody heard the name isopropyl without being in a science class?
Alcohol.
We heard an isopropyl.
Alcohol.
Isopropyl alcohol, rubbing alcohol. In rubbing alcohol, the OH group is on carbon number 2 in the 3 carbon atoms. 2, 3, 4, 5, 6, 7, 8. Now, in our drawing, we determine which one is 1, 2, 3, 4, 5, 6, 7, 8. We determine the direction. Now, again, when you actually draw it, I have to look at it and try to figure what direction you're going into. Because, again, I would do left to right, but you may do right to left. And you have the option to decide how you want to end up doing it. You can make it zigzag or you can make it a straight line. Also, a good idea to number the atoms, just to make sure you count it properly. 3, 4, 5, 6, 7, 8. On carbon number 2, we're going to add a methyl group. Carbon number 3, we're going to add a methyl group. Carbon number 4, we're going to add a ethyl group. Ethyl is 2 carbon atoms. Now you can put those 2 carbon atoms straight line, or you can bend it. You can make it to the side. Does not matter. I can put a little straight line and have it stick out together. But that would be the structure of the molecule according to the structure of the molecule according to the IUPAC name.